Example 6, find all the roots of x cubed plus 1 plus I times the square root of 3 equals 0. Write the answers in standard form. So it's basically the same structure of problem. We have x cubed plus a number equals 0. This time the number is both a real and an imaginary piece complex number. So when I slide that to the other side, it's going to become x cubed equals -1 minus the square root of 3i. So make sure that you change the signs of objects. If this said minus right here, then when you move it over, it's going to be a positive everything, but that's plus that, so that's positive, positive. When it moves over, it becomes negative, negative. Okay, this one has both a real and an imaginary piece to the complex number, so we have to go through the three-step process to get trigonometric form. So step 1, r is going to be the square root of. You want to square the two numbers, ignoring the I. Squaring things is always positive, so 1 squared is 1, square root of 3 squared is 3. 1 plus 3 is 4, square root of which is 2. Step 2, alpha equals the inverse tangent. This is absolute value, so again, ignore all minuses. Also ignore the I. We take the imaginary coefficient divided by the real number, so it's the square root of 3 over 1. Hopefully we've been seeing these enough that we're starting to know that. Inverse tangent of square root of 3 is 60. Inverse tangent of 1 over the square root of 3 is 30. Inverse tangent of 1 is 45. They've been pretty consistent about picking numbers that are pretty friendly inverse tangents. If this was inverse tangent of 17, give me some decimal approximation, that's fine. And then finally, step 3, I'm going left and down to get to this. Left and down is third quadrant. In the third quadrant, theta is equal to 180 plus alpha. So that's going to be 240 degrees. So we want to create standard form. The magnitude is 2. The angle is 240. So now x cubed is equal to that. So x is going to equal the cube root of that. So magnitude 2, CIS, angle 240 degrees. So create trigonometric form, take the root of that, applying DeMoivre's theorem. That's going to get me the cube root of 2, CIS, and then 240 divided by 3 is 80 degrees. Once again, I want to establish the magic number. The magic number, once again, always 360 on top, divided by whatever the root is, which is 3, so it's 120 degrees again. It's always 120 degrees when it's a cube root, 90 when it's a fourth root, 72 when it's a fifth root, 60 when it's a sixth root, 180 when it's the square root. So my other two answers are going to be the cube root of 2, CIS, and cube root of 2, CIS. Add 120 to 80, you get 200. Add 120 to 200, you get 320. And there's all of our answers in trigonometric form. And the final step on this one, it says write answers in standard form, so we now have to convert to standard form. Now, cosine and sine of 80, 200, and 320 aren't on our sheet. They don't have any specific nice values to them, right? So I'm going to get decimal approximations for each of these, including the cube root of 2. So it's going to look like this. Take this over here. All right, so if I type in my calculator cube root, now the way you get a cube root is this. There's a math button. Choose number 4, and then 2. Cube root of 2 equals. That's one way of doing it. Another way of doing any root is that number caret, and then put parentheses, 1 divided by the root. So the 1/3 power is the same as the cube root. Same result. So if it's a fourth root, let's say it's 18 to the fourth root. That's the fourth root of 18. Take that number to the fourth power, you get 18, right? So 1 over number, that's the way of doing a root also. But 1.2599 is the cube root of 2. I'm going to go 4 decimal places in my work to round my final 2 decimal place answers to a more accurate position. Okay, for this top one I need cosine and sine of 80, so I type in cosine 80 equals, sine 80 equals, and it tells me, and I'm making sure I'm in degrees as I do this, Cosine of 80 is 0.1736. And sine of 80 is 0.9848. Both positive. Okay, I do cosine of 200 and sine of 200. That comes out to negative 0.9397 and negative 0.3420. And then finally cosine of sine of 320. That comes out to 0.7660 minus 0.6428. So each time cosine in front, sine I in back. So sine times I, sine times I, sine times I. So you get your sine value with the I attached to it. And that gets me my answers structurally made. Now we just have to multiply it out now. So 1.2599 times each of those. I'm going to round my final answer to 2 decimal places. So 1.2599 times 0.1736 comes out to 0.22. I got to multiply 1.2599 a bunch of times, right? If I do 1.2599 store and then call it x, now anytime I type x, it's going to be 1.2599. So I can just do 0.9848. Try again. 9848 x. You get 1.24. If I do negative 0.9397 x, I get negative 1.18. Negative 0.3420 x comes out to negative 0.43. And 0.7660 x comes out to 0.97. 0.642, negative 0.6428 times x comes out to negative 0.81.
I just kept that in the radical form and multiplied it by cosine and sine every time.
That's fine. If you and that would create even more decimal places, so it might get even a little bit more accurate. It'd probably be pretty close though to my 2 decimal.
It's still the same rounded.
Okay, all right.
On our own.
I want final answers to 2 decimal places, so if you keep everything to 4 or more decimal places, you should get a pretty accurate.
Yeah, I kept them 4 when I did the answer.
All right.